For this experiment, I need a rheostat, an ammeter, a power pack, and 3 leads. A rheostat is also called a variable resistor. We move the slider along the top, and that changes the amount of wire that the current has to flow through, and therefore affects the resistance. Now if we put the slider right to this end, then the current will flow in through here, throw straight up into the slider along this piece of metal and out. And that will give us a very small resistance because the electricity is not flowing very far. If I push the slider to this side, then the current has to flow through all of this wire. And you can see the coil of wire when you get your own rheostat, and therefore, because it's flowing all that distance, there is an increased resistance. So what I'm going to do is I'm going to start with my current, my resistance as low as possible at that end, and then I'm going to connect my circuit. So I'll connect my rheostat to my ammeter. My ammeter I will then connect to my power pack, and then to complete the circuit, the power pack back to my rheostat again. Now I'm deliberately hiding the ammeter from you so that you have to do this experiment and find out for yourself. I'm going to take the voltage down to 2 volts for safety's sake, switch on the power pack, and then I can see the reading on my ammeter. As I increase the resistance by sliding the slider, I want you to see what happens to the current. So as the resistance goes up, what happens to the current? And I can clearly see this from my view on the ammeter. So that's the relationship between resistance and current. Now that my resistance is the highest, I feel safe to increase the voltage, because now I'm interested in knowing what happens to the current when we increase the voltage. So I have 2 volts, then I increase to 4, to 6, to 8, and even to 12. So what's the relationship between the voltage and the current? What happens? Off you go.